Welcome to lesson 3.4. Talked about a little bit in class, but we're using long division to divide polynomials. So think of, again, long division when you learned how to do long division with numbers. It is the same framework. It's just that instead of numbers, we're using polynomials. So it's kind of weird if you've never seen this. But it is something that once you get the hang of it, is one of the more, I don't know, I don't want to use the word easy, but it's once you get it kind of thing. Okay, so we're dividing p of x, which is x cubed plus 5x squared plus 6x plus 9 by d of x, which is x plus 3. So when you write out long division, divisors out front, dividends inside or under the long division bar, whatever you want to say, and then the quotient you build up in the new up top. So the first thing is, how many times does x go into x cubed, which is the same thing as saying x cubed divided by x is x squared. So x squared we write above the other quadratic term. If you think about long division, after you divide, you multiply. So x squared times x is that x cubed. X squared times 3 is that 3x squared. Then you subtract. Okay? When you subtract x cubed by x cubed, you get 0. When this is working right, that will happen. Otherwise, you did the previous step incorrect. 5x squared minus 3x squared is 2x squared. It's really important you put parentheses around the expression that you're subtracting. The most common mistake, and back, when we were doing school in person, and someone would make a mistake on a question just like this, and they would bring it to me and say, like, I got it wrong, I don't know why I got it wrong. I would just instantly look at the subtracting step, because 99%, maybe even 100%, somewhere between 99 and 100% of the time a mistake happens, it's the subtracting part. And it's specifically not subtracting that 3x squared, seeing the plus and just doing 5x squared plus 3x squared, getting 8x squared there. So again, make sure you're subtracting, putting parentheses around what you're subtracting will go a long way to reminding you to do that. Then you bring down the other terms, and then you repeat the whole process again. So it's that same cycle. You divide, so x goes into 2x squared, or think about it as 2x squared divided by x is 2x. 2x goes up here. Then you multiply. 2x times x is that 2x squared. 2x times 3 is 6x. You subtract. And in this case, both those terms are gone. And you bring down the 9. That would make the 9 the remainder. So you can either say that the quotient is x squared plus 2x with a remainder of 9, or you can put that remainder of 9 over the divisor and say it's 9 over x plus 3. We're not really going to do anything with that divisor in this unit. We'll eventually talk about rational functions, but that's a rational polynomial, meaning you have a variable in the denominator, which is a whole nother thing. So we're not doing anything with that right now, other than just writing it. But just understand that we will deal with that, maybe get into like adding and subtracting rational functions, graphing them, solving them, but that's a whole other unit. Okay. The other way to think about it is reverse. You take the dividend, and that's equal to the quotient times the divisor plus the remainder. Let's look at another example before we try one on our own. Kind of the whole thing is worked out for you, right? But 2x goes into 8x cubed, 4x squared times. Oh, notice how when you start with 8x cubed plus 27, there's terms missing, right? So you're using placeholders for the quadratic and linear terms, right? 4x times 2x is 8x cubed. 4x squared times 3 is 12x squared. When you subtract, you're left with negative 12x squared. You bring down the 0x and the 27. 2x goes into negative 12x squared to negative 6x times. Multiply. Negative 6x times 2x is negative 12x. Now when you subtract, 0 minus negative 18x is negative 8. 0 minus negative 18x is positive 18x. Then you bring down the 27. 2x goes into 18x 9 times. 9 times 2x is 18x. 9 times 3 is 27. When you subtract, you end up with 0. So that means there is no remainder when you get 0 there. All right. And you end up with 4x squared minus 6x plus 9 is the quotient. All right. You got a couple to try here. So pause it and then come back and we'll compare answers. Remember, for part B, you need placeholders. All right, so for any term that's not there in either the divisor or the dividend, you need a placeholder. All right, part A. You start with x cubed divided by x squared, and you get x. And then x times x squared is x cubed. X times negative 4x is negative 4x squared. X times 3 is 3x. Then you subtract. And what you're left with is negative 2x squared plus 8x. Bring down the negative 6. Negative 2x squared divided by x squared is negative 2. So then negative 2 times x squared is negative 2x squared. Negative 2 times negative 4x is 8x. Negative 2 times 3 is negative 6. When you subtract, you end up with 0. So the quotient is x minus 2. For part B, again, you needed those placeholders. So for the divisor, you need the 0x. And then for the dividend, 0x cubed, 0x squared, and 0x. 16x to the fourth divided by 4x squared is 4x squared. That's there. 4x squared times 4x squared is 16x to the fourth. 4x squared times 0 is 0. 4x squared times 9 is 36x squared. Now when you subtract, that's gone. That's already 0. Subtracting 36 gets you negative 36x squared. You bring down the 0x. You bring down the negative 85. And then you do negative 36x squared divided by 4x is negative 9. Negative 9 times 4x squared is negative 36x squared. Negative 9 times 0x is 0. Negative 9 times positive 9 is negative 81. When you subtract, that's gone. That's already 0. Negative 85 minus negative 81 is like negative 85 plus 81, so negative 4. So your remainder is negative 4. You pop that over the divisor, and that's your last term. So 4x squared minus 9 minus 4 over 4x squared plus 9. All right, let's take a look at the next example.